Good day to everyone. Like today, we will look at the third unit of metal cutting and turning machine. This is the third unit of manufacturing technology. We will just have a brief about what is a syllabic content for this unit. We're going to look at the mechanics of chip formation, the single point cutting tool, forces in the machining that they're coming, etc. The various types of chips that are going to be formed, the difference between orthogonal and oblique cutting, thermal aspects during the cutting, cutting tool materials, etc. Okay, well, we will also be looking about the different types of the machines, like the center lathe and the machine lathe, etc., the capstan lathe, all these things. What are the advantages, disadvantages? All that we will be having a look at it. Okay, now this. These are the three textbooks that I recommend that you can either purchase or go through this whenever you are in doubt. For further reading, you can definitely fall into these types of books. Now, what is machining? Machining is operated by selectively removing material. There is a workpiece which is larger than the part that is required. So you take a cutting tool and then you machine it out. You cut it out and then remove the excess material. Now this part is called the machining. How do I distinguish machining from manufacturing? Is that manufacturing is a superset of all different ways by which you can make some part, whereas machining is something where it is a particular process where you scoop out material, like for example a chip from an existing material to get the real shape and size of the part that you wanted. Okay, the various types of machining and finishing processes shown here. We have turning, we have the wire radium in advance, etc., drilling, milling machine, and the broaching. Now these are the four types of machines we should be knowing, which is fundamentals. In the advanced machining, when we go to the wire radium, we go to the chemical machining, laser machining, and water jet machining, etc. Knowledge about all these kind of machining processes is definitely required for a mechanical engineer, because he is the one who understands, or he is the one who is supposed to make what has been conceived by the designer in a physical form. Okay, so what various finishing operations, for example, for getting a good surface finish, etc., we use surface grinding machine, the centerless grinding, and then lapping machine, and the electro polishing machine, etc. Now a little amount of knowledge will be given to you all in all these processes, but then further reading is always required by the students, and I'm asking you to get prepared for this. Okay. Now, the material removal process, that's the machining process or the material removal process, is divided into three different types: the conventional machining, the abrasive process, and the non-traditional machining. It is getting categorized. This is the generic type of machining, that is turning, drilling, etc., all these kind of things. The abrasive type means it has got an abrasive wheel which grinds the surface of the part that is to be made. So it comes under the category of abrasive machining. The non-traditional kind of machining does not use these kind of things. It doesn't have a cutting tool, etc., but it uses energy like mechanical energy, electrochemical energy, thermal energy, or the chemical energy for removing the material and then bring it to the required shape, etc. Now, why is machining required? Parts which are there in our components are generally have their own sizes, shapes, form, etc. In order to get their kind of form, we are using manufacturing, but machining is more required because the shape must be more conforming to the dimensions that is there, and as well as the surface finish that is there. So improve the dimensional accuracy, tolerances, etc. We try to use the manufacturing process. Then it is one way which is easy and economical to do a part for its correct shape and size. Okay. Now the next one we will look at is a simple way, like what does this entire machining process require? It requires power. It requires a blank which is of a slightly larger size than the required component, a machine which will hold the part, a fixture which will hold the part, and a machine which will give the required energy to of the cutting forces, etc., all that. Then you require the tool for cutting, and then you also require the power for the part to rotate or the machine to run. So all these things put together is what is required out of a machining process. Now you see here, the cutting tool is shown here, and then the machining process is really shown here. Well, it requires a cutting speed which is measured in meters per minute, and a feed which is measured in per revolution of the part. And the depth of cut is the amount of push that has been given onto the tool into the work material, and that will take out the size of the chip. Okay. Now, as the tool progresses like this, this is the work material. It plunges into the material, and then it scoops out the material in a form of a chip. Now, this is a chip which is in a serrated form, and then on the top it rubs the face of the tool, and then it moves out. Now, this is the new surface, and this is the original surface. So this difference between the new and the original surface is your depth of cut. Okay. Now, let us continue. Now, we're looking at the different type of parameters. We have shown you the three parameters that are required for the machine. One is the cutting speed, then the feed, and the depth of cut. Okay, cutting speed is the distance traveled by the work surface in unit time. Okay, so as it rotates, it is a RPM into the diameter, etc., like that. So the cutting speed V is simply referred to as a speed, or usually expressed in meters per minute. It is denoted by V, and it is given by pi d n by 1000, and where d is in diameter in mm. Okay, and n is in the RPM. Now, because we are looking at the circumference, that is why the pi d comes into it, and this is your RPM, n is the RPM, and that is how we calculate the cutting speed. So please do not mistake that the spindle speed is equal to the cutting speed. No, they two are different. Okay, spindle speed is n, okay, and cutting speed is given by V is equal to pi d n by 1000. Okay, now what is feed? Feed is the distance advanced by the tool along the workpiece. Okay, as you push inside, how much you scoop on the sideways towards the chuck, how much you move there. Now that is what is given as the feed. If I don't give the feed, it will be rotating in the same place, and there will not be any further material taken. So I have to push the tool in the linear direction towards the chuck. Now feed in is measured in per minute. What is the amount of do I move it laterally? Okay, in a minute, or the number of revolutions per minute. Now, depth of cut is the distance through which the cutting tool is plunged into the work surface. Now, this is the distance measured perpendicularly between the machine surface and the unmachined or cut surface. Now, too much amount of depth of cut is going to require more power for it to be cut, and then very less will also you'll be wasting power. The adequate amount of depth of cut is very important, and it is expressed as the original diameter minus the second diameter, and then divided by 2. That is the depth of cut for turning. Okay, so in this video, we have seen the introduction towards the machining process. Okay, we looked at the various units that we are going to handle in this in this particular unit. The center lathe, etc., will be covered a bit later. Now, we also introduced to you the textbooks that we expect you to go through. There's the book called Kalpakjian is a very nice book, and for problems, etc., anything related to the machining, the problems, this book I would suggest that you can go through this. And this is a very, very comprehensive book. We also looked at what is machining. We looked at the various different types of machining processes. Today we have started off with turning, but then we will also move on to the drilling and the milling part. These two are the main kind of machining processes, and broaching is also a kind of process, but we will more for internal components that we will look at it later. Now, coming to the advanced one, you have the wire radium and the chemical machining and the laser machining, etc. And for the finishing process, in order to make the surface very smooth, how do you measure the surface smoothness? It is measured by a surface measurement instrument, okay, or tally surf, etc., like that. And then you measure it, the waviness or the surface roughness using this instrument, and it is denoted by RA value. Okay. Now you have a centerless grinding, you have a surface grinding, and then you have the lapping, which is a much superior process than the surface grinding, and the this one more smoother. And then you also have the electrochemical polishing. Okay. Then we looked into the various types of material removal process. We also looked into the why do you have to go into this. You see the milling part here, more of prismatic components can be done here. Everything is symmetry about an axis is what is being done here. Okay. And so this is the different types of milling. We'll look at milling. Internal and external surfaces also can be done using this. And we looked at um, the the mechanism of chip formation. Okay, as the tool cuts into the surface, okay, with a velocity and then motion of the tool relative to the work, and then you have this cutting tool here. The chips get really sheared along the surface, and then it goes along this. Now this part is more harder than the painted material because this have undergone work hardening. This is an interview question. Okay, it has gone work hardening. Now you must also understand that the tool must be more harder than the work material, otherwise this is not going to cut, and this itself will get cut. Now between the apple and the knife, which is harder? If you want to cut the apple, then you have to have a knife which is harder than the apple. So that is the requirement here. This is the shearing deformation zone, and as it comes here, the material gets crushed, and then it gets sheared out, and then you see this is a chip coming out. The size of this chip is always larger than the depth of cut. Okay, that also keep that in mind. So finally, we saw the cutting the definition of the cutting speed. The units are very important: cutting speed, feed, and the depth of cut. And we looked at the formulae that these three parameters are to be calculated. And initially, we use cutting speed can always be measured. Feed is what we give. The depth of cut is also what we give, but the forces, etc., coming on for the cutting is not to be measured. So use a separate instrument called a dynamometer. Okay, called as a lathe dynamometer. Using these lathe dynamometer, we will start measuring all these forces. So I have revised this class. I hope this is informative. If you have any questions, you can always post me. Thank you all very much. Have a nice day.